Okay, let's dive right into this. Welcome to This Explainer. Today we're going to unravel a true physiological whodunit. It's this everyday, kind of bizarre mystery that I'm sure you've pondered at least once in your life. We're looking at the weird, wonderful science of ticklishness. And specifically, we're going to finally answer the question, why on earth can't we tickle ourselves?
It's a total universal paradox, right? I mean, just think about it for a second. We can be thrown into absolute, uncontrollable fits of laughter if a friend just lightly pokes our ribs. It's this intense, whole-body reaction. But if you take your very own hands and make the exact same motion in the exact same spot, literally nothing, why does our body react so violently to someone else but totally ignores our own touch?
Well, think about external touch. When someone else tickles you, there is this massive element of surprise. It's totally unpredictable, and it just triggers this uncontrollable burst of laughter. But when you touch yourself, your brain is completely in the driver's seat. It's predictable, highly controlled, and the result is zero laughter. As you'll see, the difference between these two scenarios actually lies deep, deep within the architecture of our nervous system.
Section 1. The brain's prediction machine, finding the culprit.
So let's kind of open up the hood and look inside the anatomy of the brain. Meet our primary suspect, the cerebellum. It's sitting right at the back of your skull, and its main gig is to monitor your movements. But more importantly for our mystery, it actually predicts the sensory consequences of your own actions. Basically, the absolute second you decide to move your arm to, say, tickle your own stomach, the cerebellum immediately shoots out a mass memo to the rest of your brain saying, "Stand down, guys, it's only me."
And you know, the cerebellum doesn't work alone. It's constantly chatting with other regions. When someone else tickles you, your somatosensory cortex, which processes physical touch, and your anterior cingulate cortex, which processes pleasant sensations, they light up like a Christmas tree. But when you try to tickle yourself, the cerebellum essentially acts like a mute button. It predicts exactly what you're about to feel and just actively shuts down the response in both of those cortices. You simply cannot surprise your own brain.
This whole process just brilliantly illustrates the core of our mystery. Dr. Sarah Jane Blakemore over at University College London really hit the nail on the head. She said, the cerebellum can predict sensations when they are caused by your own movement, but not when they are caused by someone else. Our brain is literally a prediction machine. It evolved to filter out the unimportant background noise of our own movements so we can stay hyper-alert to the outside world. I mean, from a survival standpoint, feeling your own shirt brushing against your skin? Totally irrelevant. But feeling a spider crawling up your arm? Yeah, that is a matter of life and death.
Section 2. Kinemesis and gargalesis explained. Two very different tickles.
Before we go any further down this rabbit hole, we really need to clear up a massive misunderstanding. Not all tickles are created equal. First up, we have kinemesis. This is that super light, feather-like tickling sensation. Think of like a blade of grass brushing against your bare foot. It doesn't make you laugh at all. Instead, it feels like an annoying itch, and it triggers an immediate reflex to scratch or rub the spot. Evolutionarily speaking, this is highly functional. It's basically our built-in alarm system to swat away crawling bugs or parasites. And get this, the response is so primal it works on a ton of animals. If you lightly touch the sensitive area just under the snout of a great white shark, it actually induces a kinesis response that can put that massive predator into a near-hypnotic trance. Wild, right?
But then, on the flip side, we have gargalesis. This is the heavier, laughter-inducing tickle we all associate with, childhood play. It involves repeated, higher pressure to very specific supersensitive areas of the body. Unlike that light itch of kinesis, gargalesis is incredibly rare in the animal kingdom. We really only see it in primates, like us, and fascinatingly, in rats. So the crucial takeaway here is this. When we say you can't tickle yourself, we are talking specifically about gargalesis. You can absolutely give yourself a kinesis itch, for sure, but you literally cannot induce a gargalesis laugh.
Moving on to Section 3, the evolution of laughter. Why do we laugh when attacked?
So why on earth did humans ever develop this bizarre reaction to gargalesis anyway? Why does our brain interpret a physical attack on our ribs as a cue to just absolutely lose our minds with joy? Well, the answer seems to lie in combat and survival. Back in 1984, psychiatrist Donald Black noticed something incredibly insightful. He pointed out that the most ticklish parts of the human body, like the neck, the ribs, the armpits, are actually our most highly vulnerable zones in hand-to-hand combat.
Evolutionary biologists think tickling evolved as a way to encourage rough-and-tumble play. Basically, tickle fights let kids practice protecting their most vital, vulnerable areas while honing those defensive reflexes. And they get to do it all within a safe, socially bonded environment. And this connection to play is just incredibly deep-rooted in our ancestry. Neuroscientist Robert R. Provine summed it up perfectly. He noted, "The ha-ha of human laughter almost certainly evolved from the pant-pant of rough-and-tumble human play." When scientists watch apes, like chimps or orangutans, having these intense tickle battles, the animals don't vocalize a human laugh, but they do let out this really intense rhythmic panting. Over millions of years of evolution, that primal pant of playful exhaustion gradually transformed into the vocalized ha-ha we all recognize as laughter today.
Section 4. What ticklish rats teach us: ultrasonic laughs and joy jumps.
Now, to truly decode the neurology of tickling, scientists turned to a pretty surprising animal model in the lab, the rat. And honestly, this led to some of the most delightful scientific discoveries. When researchers tickle the bellies of rats, the animals emit these 50 kilohertz ultrasonic vocalizations. Now, we can't hear them with our naked ear, but if you use special microphones, it sounds exactly like highly modulated chirping or laughing. Not only that, tickled rats do what German scientists call Freudensprünge, which literally translates to joy jumps. They get so excited they just leap right into the air. Studies prove this is super rewarding for them. It completely lights up their brain's dopamine system. And just like human kids, simply playing, like chasing the scientist's hand around their enclosure, triggers those exact same joyful ultrasonic laughs.
This paints a really fascinating picture about human mood and ticklishness too. When researchers tested those same rats in a cozy, dimly lit control environment, the rats laughed all the time, jumped for joy, and the neural firing in their somatosensory cortex was super active. But when they put them in an anxiety-inducing environment, like a brightly lit, elevated platform, the tickling response completely shut down. The vocalization stopped entirely, and the actual neural response in their brain decreased. It completely proves that ticklishness isn't just some hardwired physical reflex, it's totally dependent on your psychological state. If you are anxious or scared, your brain actively suppresses that whole play response of gargalesis.
Which brings us to Section 5, Hacking the Tickle, Exceptions and Delays. All right, so we know the cerebellum cancels out self-tickling, and we know our mood can kill a tickle response. But this leads to the ultimate question. Can we somehow hack our brain's prediction machine into letting us tickle ourselves? Well, there's actually a medical exception that proves the rule. Studies show that some patients suffering from schizophrenic hallucinations actually can tickle themselves. This is a massive neurological insight. In these individuals, the brain's predictive processing operates a bit differently. Their cognitive ability to tell the difference between a movement they produce themselves and a sensation coming from the outside is somewhat reduced, because their brain doesn't properly send that stand-down signal from the cerebellum. Their own touch registers as surprising, and they actually feel the tickle.
For the rest of us, though, we can hack the system. We just need a little technology to do it. Let's walk through this absolutely brilliant experiment designed by Dr. Blakemore using a robot. Step 1. A person moves a joystick with one hand. Step 2. A computer introduces a fractional, tiny time delay to that signal. Step 3. A robotic arm, which is being controlled by that joystick, tickles the person's other hand. Now here is where the whole mystery unravels. When there was zero delay, the subjects felt nothing, just like normal. But the absolute second the computer introduced a tiny delay, I'm talking just 0.2 of a second, between moving the joystick and feeling the robotic tickle, the subjects found it incredibly ticklish. By just adding that tiny delay, the cerebellum's prediction was thrown off. The touch became surprising again, and they successfully bypassed their brain's own internal security system.
Finally, I want to leave you with one surprising number: 40. Studies show that as we age, our susceptibility to being tickled naturally trails off, and it mysteriously drops right off a cliff around the age of 40. After that intense gargalesis tickle response mostly just fades away. Which leaves us with this really fascinating unanswered question. If tickling evolved as this absolutely crucial tool for kids to hone survival reflexes and forge deep social bonds, why does our brain just suddenly decide we don't need it anymore once we hit middle age? Think about that the next time you try and inevitably fail to tickle yourself. Thanks so much for joining me on this explainer, and as always, keep asking questions.